So thanks to Adam for allowing me to present with Prezi Next AR. And I also have to thank the various companies that I will be mentioning during my talk, because this is all about collaboration. It is unreasonable to think that something in this industry can be done by one company alone. And collaboration takes more courage than competition. And it is a leap of faith to open yourself up to another company, but the rewards are much greater than working alone. So, by a show of hands, who has worked with Lego? Okay, all right, that's good. How about Tinker Toys? Okay, a few less. Now, Lincoln Logs. Wow, okay. We have an experienced group here. We all love to build things. This one here, that's my daughter. She's now 18 and going to college here in Boston. So that was the San Francisco Bridge that she built, of course, with my help when she was much younger. But we love to build things. And just like the alphabet, we build things by using simple blocks to bring things together to make complex structures. We start with 2D paper, ink, and rulers. And of course, these are the 1950s, and this was the state of the art at the time. I don't know, maybe some of you also remember the mechanical erasers. That was a big thing then. And of course, when CAD came around, we thought this was the end all. CAD was going to be here forever. Well, I'm going to challenge that assumption with something that I think is going to make this conference a little bit more worthwhile than it already is for all of us. And that is to give an overall vision that brings this all together. One of the clients I met with said, "Oh, you're talking about the Holy Grail." I said, "Well, if that's what you want to call it, that's fine with me." The problem that we have in engineering is that there's three big components to data, which is the design data, then we have plans that are used for building, and then we have manuals that are used for operation and maintenance. But unfortunately, in each one of these steps, we lose information. In fact, there's a thing called as-built plans, which have nothing to do with the design plans, but then the operator of the building or the refinery just gets sort of a booklet that gets thrown into a drawer and never looked at again. So, and one of the things that I heard in the other talks is, what's the economic motivation for all this? Well, it turns out statistics are hard to come by in this field. But according to the American Association of Heating, Refrigeration, and Air Conditioning handbook, that 80% of the total cost of ownership of a building comes in the third stage, which is that of maintenance and operation. So think about it this way. If you're designing a building and you decide to save by not putting insulated glass because you're going to save a few bucks on that window, but if you take that operation over 30, 40 years, you're being incredibly stupid because you're paying more in the long run. But in order to get those statistics, you need to have a simulation of a building over 30, 40 years. That is unheard of at this moment. So there are statistics, mostly from the building industry, but from what I've gathered, there's other statistics, and those of you who might be interested, I can give those to you later. But essentially, between 60 and 85% comes in what is the long term of the operation of the building. And we believe that this obviously would translate to refineries or airplanes, other complex devices. And it has to do with this curve, that it is very expensive to make changes towards the end. So at the beginning of a project, making changes doesn't cost much, But as the project moves along, the ability to make changes decreases, and the cost to make that change increases. And sadly, here's where ERP stands, which is much after the fact of when things have already been built or designed. So it's like trying to fix something that's already been installed. And this is the gold mine that I think that AR is looking for. How do we justify all of this technology? Well, this is starting to show us where this happens. And there's two big kind of very boring topics, which are, one is project lifecycle management, PLM, which is, there you go, the business activity of managing a project across its entire life cycle in the most effective and profitable way. And curiously, there's another force called BIM. Many of you have probably heard about this, which is trying to do the same thing. We're actually part of a government initiative to work on BIM in Spain, which is where I'm working now. So, but here essentially we have the famous words here: reduce costs, operate more intelligently, build better buildings, improving efficiency, and collaborating. So, moving on. I'd like now to present, this is a video, but we actually have an interactive demo where we set up 4 computers, Alienware machines, curiously the same machines that a lot of gamers use, because we need the power of the graphics. So what we've done here, because I'm mostly in the industrial field, is to import directly from the plans an entire refinery. This took us about a week to do. So we're not creating new information, we're repurposing existing information. But in its final version, this would be an entire refinery operating in real time, and you can zoom in on any of the objects or assets, and that information has been provided by the supplier of that asset. So you're not punching in a lot of data, and you're getting it right from the horse's mouth. Now, this is just, like I said, a simulation, and it looks curiously like a video game. And the people are working inside the refinery, and they're located with explosion-proof phones, because in a refinery, you know you can't use a normal phone. But all of these people are geolocated by their phones, and here we simulate a problem in the refinery. In that red color, that machine has a problem. All of the people that are in that refinery are also scanned and biometrically identified. I'll show you that later. We contact the person that's qualified to handle that incident. And this could be through a text message, but because we're assuming we have low bandwidth in many of these places. And this would be the supervisor's view looking at where the person is walking. By the direction of their travel, you sort of know what they would be looking at. But then, of course, once they're in front of the problem, we open a telepresence window up here in the right, and we're actually seeing what that person sees in real time. Now, this could be done, and we're doing it now. We sell a telepresence device, which is a camera connected to an Android phone, but this could also be an AR device in the future. But again, we have to start somewhere. And telepresence, okay, here what we do is we pull of the part that needs to be repaired from the database of parts that we already have from the refinery, because, of course, all of the parts of the refinery have been saved in a big data database. Now, the database is key. They say all businesses in the future will be data businesses. Imagine a refinery or an airplane that has hundreds of thousands of parts. So we save all of those parts in a big data database. And this is the progression that we have. We've started with 3D geometry. That would be a CAD, AutoCAD or SmartPlan 3D or any other CATIA. We move up to 4D, which is adding the time element. 5D would consist of the cost information of that object, of that part. And that would be where the cost of the project is stored. But now we move to 6D, and this is where each part in the refinery has a serial number or an IoT address. And now we're starting to do magic things, because I can have an entire refinery that is, sorry, I'm stepping over my markers here. We can have an entire refinery that has been identified down to the last bolt. And also the robots are identified in this environment, and the humans are also tagged, so that anything that happens, we create a digital thread of everything that happens in that environment. But it gets better. I call it 7D, sentient machines. And this is not science fiction. Right now, jet engines, like General Electric has a company called Predix, which is monitoring a jet engine in flight, and it takes the temperature, the pressure, vibration, and it is comparing those parameters to other jet engines that are flying at that time, so that any outlying value that shows that there might be a problem gets immediately reported to the maintenance personnel or to the pilots to shut down that engine or to inspect it upon landing. So if you have this entire infrastructure where you are maintaining the information of the objects throughout the entire history of the plant or the plane or the building, you have exabytes of data. So this must live in the cloud. And it must live in the cloud in a meta standard that will allow it to be analyzed in the future when artificial intelligence machines can improve the efficiency of this, but still use the same data. I irk at the thought that we have a beta versus VHS battle again on standards. And it's sad when I see patent applications that are trying to patent gestures, when we should be collaborating and trying to help all of us work on common standards so that we can work better and faster and cheaper. That's my little speech for that part. Now, there's no purpose in having all these parts that are dumb parts. So what we found is a partner called LTX, they're in Germany, that adds physics to the parts. And this is a Swedish association that does open source physics that gets imbued in the parts. This is another partner that we're working with. It's called Kisters. They're also German. And they can render hundreds of thousands of parts on a cell phone. So the idea is that if you have a complex refinery or building and you're changing parts, you can do a static model using Unity. But normally what you would want to do is to have something that allows you to change on the fly. And why is this important? Because you have a collaborative environment where hundreds of people might be working on the plant at the same time, and they need the latest information to be able to make the right decisions. All of these parts are blockchain protected so that access is only granted to those people with the appropriate authorization. That makes sense. There might be parts of the jet engine, like the fan blade geometry, that you don't want to share. So that can be grayed out to only provide the information to those who need to know. I said before that we scan the people in this environment. So instead of thinking of AR, VR as sort of something you wear and you're in this environment, we can think of a global community of people working on a project that may or may not be there, but that are virtually or in an augmented manner working side by side so that a worker at a factory can look over with their augmented glasses and see somebody who might have retired from the company or a handicapped person that is working from home. So this already exists also. It's basically like an airport scanner. It scans you biometrically because you're going to need security. I know customers that say, I'm not going to allow somebody to put my industry data, my refinery data on the cloud. It's going to get hacked. So it could be hacked by an avatar. It could be hacked. So again, the blockchain security is definitely an important part of this. Now, this is, again, a collaborative effort. This is a French company called Middle VR in Paris. And they use this now industrially to certify workers in the operation of gas distribution points. It's a beautiful demo, but it's real. You can see they're using an HTC Vive to operate, and you can see the pressure of the valve changing as the person operates the valve. So all of those parts would live in the big data database and get rendered on the fly in this collaborative workspace. And again, the ecosystem gets larger and more synergistic because there are already several companies that provide millions of parts in catalogs that you can pick and place into 3D design. So for example, here's BIM Object. I happen to know the people who work there. And they have 25 million BIM objects. Again, here we get the BIM and the PL. Every industry uses different words. But I want to show you that, for example, these parts that you see here, they're all in the database. And then you can drill down on a specific part and get all of the geometry, the metadata, the cost, if you're authorized to do so, and import this into your project. And I'm glad to say that just a few weeks ago, a small multi-billion-dollar Spanish engineering company called Saphir, they happened to build the expansion to the Panama Canal. They decided to work with us on a project to monitor 40 desalination plants worldwide, which are complex plants that use huge pumps to push water through reverse osmosis filters and require a huge amount of maintenance. So they were interested in how much they're going to save by incorporating this philosophy and then, of course, all of the AR and VR technology, but mostly just to know what's happening and avoid travel costs of people going all around the world. So they built the Super Panamax expansion. They're all over the world. It's an amazing project. And here is an image of a plant that they have in Oman. And this is just using Navisworks. But the point that we show here is this complex structure with turbines. And now this is the best part, where we're going to fly into where they actually have the batteries of the osmosis filters. So you can see the racks of those filters where they push the salt water through to get the clean water on the other end. But imagine all of those parts in a database, knowing the maintenance requirements of all of those parts for 30, 40, 50 or more years, and imagine the software that we'll have to improve the efficiency of these parts in the future. So obviously, we love these images. This is, of course, the HoloLens. But where the hell are they going to keep all that information? Nobody's talking about that. So what we're proposing is an open source, blockchain secured, big data, cloud-based data repository that would import standards like IFC, ISO 15926, which is what the Norwegians and the Germans use to document all of their petrochemical projects. Aviation has a standard called STEP, but great news. All of these standards are based on essentially the old printer language, SGML, which in many of these standards has been reduced to XML text fields. So we have the XML text fields. We have the graphics or the blob that can be added to these databases. And then we have the entire object secured with blockchain so that those objects cannot be improperly modified. We again emphasize the concept of very sophisticated collaboration at a distance. And all this will happen, and it'll happen sooner than we think. I look back and we say, well, you know, it was in the early 1900s when we were looking at Kitty Hawk and the first Wright brothers, and now we think nothing of walking into these huge structures that fly us across the earth, and we just complain about whether the movie we have is not good enough. But it's an amazing travel in the last 100 years of very sophisticated technology, and we can see that the bright minds of here and other places that are working on these devices. But it's more important to think about the economics of the data that has to be stored and shared in such a way that you have a refinery that is in some proprietary standard today, but that company changes, merges, gets bought out, and tomorrow you don't have any access to the information that was used to build that plant. That is a huge waste. So again, in finishing, what is Talent Swarm? Because the problem is, since I've talked about, you know, smart objects, avatars, AR, VR, well, I like to summarize it in these 5 points. Data, platform as a service with an open source blockchain secured long-term data, big data repository. If DARPA had not given us TCP/IP, we would probably be using, I don't know, smoke signals. But that standard that was given to all of us, really to ensure survivability in a nuclear war, which had nothing to do with what we're here to do today. But amazingly, creating that standard created this I like that, Precambrian explosion of technology. The savings drives the industry. It's nice to get pilot projects, you know, to test these devices out, but unless the people that write the checks aren't going to get a huge benefit from using this technology, it won't happen. Just the fact that the information from the operators and maintenance people gets fed to the designers that are designing these buildings or refineries, and they're using pick and place catalog parts from suppliers. That means that the entire logistics chain gets disrupted in a good way. And that's what I mean here. We have access to millions of parts with digital rights management so that those parts can't be inappropriately copied or duplicated, which is a big problem in the aviation industry with fake parts. So you don't want to give away the way to build a part to the people who should not have that. With the 3D geometric data and the metadata and the supplier links that can create a huge marketplace opportunity for people that are selling their products worldwide. And that is already done. I mean, I'm not adding anything new. I'm just saying, let's take advantage of all these people already documenting their parts and bring those parts together so that the designers can look at a life cycle simulation using the Open Modelica physics so that I can build a virtual building and know how it's going to behave in 30 years. I run an engineering company in Spain. Our specialty is outsourcing highly qualified engineers to other engineering companies. That's kind of how we got to the talent swarm concept, because we can't find enough good people. And our customers need them to fly all over the world. Why fly people overseas when they could virtually enter that project and work side by side with an operator virtually? The hardware will come. Eventually, it'll be an implant into our brain. Forget the contact lenses. That's all going to come. But really, the access to talent is what a lot of large engineering companies are worried about. People are shying away from the STEM curriculum. And the collaborative work environment to foster collective intelligence over competition. And again, this is not something I've invented. Nature has beat us to the punch a long time ago. And I think this is beautiful to watch. And it should be an inspiration to us. Measly ants using their bodies to create a bridge. But it's not just the ants. These fish swim together to protect themselves from the shark because they have thousands of eyes that are looking where the threat's coming from. And the starlings in England do the same. They do this so that they can hunt, but mostly because the hawks that are above them cannot dive into the flock because they would break their wings. So thank you for watching, and I look forward. My ask is that if there are people in the audience that think that this is a compelling vision for the future, please come and see me. As you see, we're working with a lot of different companies, and we would love to add more to the fold in an open source yet protected way, so that we're not just doing this. We do it for the goodness of our heart, but really for an advancement of humanity. I'll finish with this. And since John is such a buff of movies, I think you might remember a scene in Contact with Jodie Foster, where they're trying to figure out what this signal from this extraterrestrial signal means. And they realize that the extraterrestrials are sending standards, a sample of how to build the machine to teleport her to okay, you probably know the reference. And mathematics is the universal language. And what we're talking about is to take the existing standards in the different industries. We've already studied this, including with the military, to bring those standards together in a meta standard in big data, which can change with time. We're not talking about creating a new standard, but simply to bring this information together, to create the digital twin, to keep the digital thread for decades, and to share all this information for projects that cost less and justify many, many hardware purchases. Thank you. Woo!